Hello, student. Welcome back to this chapter of chemical reactions and equations of the 10th standard CBSE or ICSE or state syllabus. So in the last session, I have discussed the question and answers of this chapter, chemical reactions. Just I will revise what I have done in the last session. So we have seen what is the answer for this a chemical reaction. What is a chemical reaction? Give an example. So this we have studied. And the next question answered is what is a chemical equation? What is a word equation? What is a balanced chemical equation? Give the classification of chemical reactions. What is a combination reaction? Give an example. What is a decomposition reaction? Explain its types with example for each. And what is a displacement reaction? Explain its types with an example for each. So what are oxidation and reduction reactions? Give an example for each is also done. Okay, so here up to this we have done in the last session. What are redox reactions? Give an example. So the reactions in which oxidation and reduction takes place simultaneously are called redox reactions. Here I have given an example. CuO is the calcium oxide. When it combines with the hydrogen, it produces a copper metal plus the release of the water. So here copper oxide is reducing to copper where the oxygen is removed and hence it is a reduction reaction. Whereas the hydrogen forms the oxygen to make the water H2O. Here oxygen is added to the hydrogen and hence it is a oxidation reaction. So in this particular chemical reaction, the reduction and the oxidation process are taking place simultaneously, and hence these are called as the redox reactions. So next, what are exothermic and endothermic reactions? Give an example for each. Just I revise it. So first we'll see what are the exothermic reactions. The reactions in which heat is released along with the formation of products are called exothermic reactions. Here is the example. Methane is there, CH4, which is it gaseous form, combines with oxygen in gaseous form, and the products formed are the carbon dioxide in gaseous form, and water vapor is also produced here, plus release of heat. So this is an example for exothermic reactions, and in this reaction heat is evolved or released. So next is the endothermic reaction, the reaction in which the absorption of heat or energy takes place are called the endothermic reactions. This is the example. So NH4Cl, ammonium chloride, which is in solid form, when you heat up it produces the NH3 ammonia, which is in gaseous form, plus hydrochloric acid is also formed. So this is the equation where the heat is absorbed. So it's an example for endothermic reactions. Okay. So next we will move to the question. What is corrosion? Explain with suitable examples. So corrosion is a process of gradual conversion of metals into It's a compounds, generally oxides, by the interaction of air, moisture, or water, and chemicals present in the atmosphere. So that is called as the corrosion. Examples are reddish brown coating on the surface of the iron. Generally, we have seen if the iron metal is exposed to the atmosphere, open atmosphere, what happens? Generally, its surface becomes reddish. So that shows that the corrosion has taken place. And black coating on the surface of silver articles, if you keeping it for longer time in the open atmosphere, they also become blackish because of the formation of the oxide, silver oxide over the silver. And the next example is the green coating on the surface of the copper. Copper also gets oxidized if you with the when it is exposed to the water content or the moisturous air. So corrosion of iron is known as a rusting. That is the name for corrosion is the rusting. So next question is, what are the effects of corrosion? Corrosion deteriorates the strength of the object, which are made up of metals such as iron and copper. So what happens once the corrosion has taken place, the strength of the material becomes very weak. So easily they break down. So it's called as deteriorate, gets deteriorated. Next, due to corrosion, every year tons of metals are wasted, especially the iron. Thus, it's a wasteful process. So we have seen every year the tons of iron material becomes waste because of this process, and hence we can consider this as a wasteful process. Next question is how the corrosion of metals can be avoided. Following methods employed to prevent the corrosion. So the first one is painting. Just you paint over the metal surfaces, you can avoid the corrosion. Applying grease or lubricant, you can apply the grease or lubricant. Alloys are not prone to the corrosion process. So alloying means you have to mix some other materials. For example, steel is there. Steel is a combination of iron and chromium. So what happens when iron and chromium mixed together, it becomes a steel. So because of that chromium added into the iron, it becomes a non-corrosive material. So it's called as alloying. Galvanizing. So aluminum, copper, and silver can be galvanized. That means with the help of passing an electric current, we can make galvanizing so that a coating is formed over these metal surfaces. Anodizing and chrome plating. So these are also similar methods you can apply to avoid the corrosion. Next is, what is rancidity? When the food materials are exposed to open atmosphere for longer time, the island fats present in the food gets oxidized. This changes the taste of the food and odor smell comes out. This is referred as a rancidity. That's why we should not eat the food materials which are kept open in the roadside. Many times when we eat the roadside food, our stomach gets troubled. So it's because of rancidity. So this phenomena is called as the rancidity, and we should avoid it. So mention the methods to prevent rancidity. Rancidity can be avoided by these following ways. So cooked food can be kept inside a refrigerator. So refrigerators are invented for that purpose. We have to keep the cooked food inside the refrigerator so that we can preserve it for a longer time. And food can be kept in a airtight container so that oxygen doesn't come in contact with the food, and hence the rancidity is avoided. And next is food or bakery items kept inside a special package which contains nitrogen gas preserved for longer time. Sometimes what happens, some food materials are kept inside a special package which contains the nitrogen gas. Nitrogen gas is a neutral gas. It doesn't allows the oxidation process. That's why nitrogen gas is used. So it is another method. Avoid direct sunlight. So whenever you keep the food directly into the exposure of the sunlight, what happens? The rancidity is more. The things gets converted into some other form. By adding antioxidants, usually, namely BHA, that is butylated hydroxyanisole, and BHT, butylated hydroxytoluene. So these are the chemicals which are mixed into the food item to preserve it for longer time. But even though they avoid the rancidity and keep the food for longer time without spoiling, but the effect of these two on the body is to be think separately. So that is another chapter is there. Next question is, what do you mean by the precipitation reaction? A double displacement reaction is called a precipitation reaction because in a double displacement reaction, a precipitation is formed. So that's why precipitation is something like a suspension in the semi-liquid form. So something is floating, will be floating inside that chemical. So that kind of state will be mixed, will be reached by the two chemicals. Then we say that precipitation is formed. So give some examples of chemical reactions occurring in our daily life. So these are the chemical reactions, souring of milk. So if you kept the milk unheated or warmed for longer time in the open space, it becomes sour. So that's another one problem. Formation of curd from the milk is also a chemical reaction. Process of inspiration within our body is a chemical reaction. Cooking of food is the reaction. Digestion of food in our body, formation of grapes. All these are the natural reactions which are taking place in our daily life. So how do we come to know that a chemical reaction has taken place? This is the question. So when one or more of the following observations are confirmed, we say that a chemical reaction has taken place. So we should look at this, whether the change in state has taken place. Means change in state means a liquid state may convert into solid state, or solid state may convert into liquid state, or a liquid state may convert into a vapor state. So these are the changes in the state of the material or a chemical. So we have to check it. Then change in the color. Sometimes there may be change in the color, and new substance may be formed, and change in temperature. Temperature of the material also changes. Precipitation may be formed when the two things are mixed together, and some gas may be evolved. So these are the things we have to look at to confirm that a chemical reaction has taken place. So next question is, mention the steps involved in balancing a chemical equation. So in the first session, we have seen what is a chemical equation. chemical equation is the representation of a reaction by its by the formula of the compounds involved in that reaction. So a chemical equation is balanced based on the fact that mass can neither be created nor be destroyed during a chemical reaction. So this is a very important basic law in nature, or it's called as the law of nature. Mass can neither be created nor be destroyed during a chemical reaction. Only it turns from one form to another form. So it's called as the law of conservation of energy. And thus the total number of atoms of each element must be equal on product and reactant sides. The steps involved in balancing a chemical equations are as follows. So write down the unbalanced equation and enclose the formulas of reactants and products in a bracket. So this is the first step. Count the number of atoms of each element on the product and reactant sides of the equation and make a table. In the below, I will give the example, then only you will understand what is this really. So next step is from the table, choose an element which has a maximum number of atoms and first balance it. Next step, write down the resulting equation and then balance the remaining elements. Then remove the brackets to obtain the balanced equation. So this is these are the very important steps you have to follow to balance a chemical equation. So now we will see an example. This is an example is there for the chemical equation. So balance the following chemical equation. C6H6 C2H6 plus O2 gives rise to CO2 plus H2O. So this is the a chemical reaction. And now we have to balance this equation. So first you write down the given chemical equation as it is. So here we have written the given chemical equation. This is the step one. This is the first step. Then the step one is put the bracket into the compounds involved in reactant and product side. So this is the reactant side. This is the product side. So we are keeping every compound into the bracket. So C2H6 is there. It is placed inside a bracket. This is the oxygen, keep inside a bracket. This is the carbon dioxide, keep inside a bracket. This is the water, keep inside a bracket in this way. And now we check how many atoms of each element are there in the reactant side and the product side. So what are the elements present here? C means carbon is there, H means hydrogen is there, O means oxygen is there. So these are the elements involved in this chemical reaction. Then look at the number of atoms in LHS side. LHS side means reactant side here. So how many carbon atoms are there? 2. Here you see 2 are there. How many hydrogen atoms are there? 6. So here H6 is there. So 6 six carbon atoms are there, and here and oxygen you can see here O2 oxygen, two oxygen atoms are there. This is on reactant side. On product side, you see product side only one carbon atom is there. See here you see carbon, only one carbon atom is there, and 2 hydrogen atoms are there. Here H2. So here 2 hydrogen atoms. And look at this multiplied by 3. I will explain what is this later. So there are 2 hydrogen atoms are there, and next oxygen 3 are there. Here 2 are there, here 1 is there, 2 plus 1 is a 3. So these are the number of atoms of the elements present on the product side. So look at this table. What is clear is that hydrogen atoms are more in number. Here 6 are there and here 2 are there. So we have to balance the hydrogen first. So what we are doing, how we are balancing, you see, on reactant side, 6 hydrogen atoms are there. That's why, but on product side, only 2 hydrogen atoms are there. That is what I am doing. I am multiplying these 2 to 3 to make 6. Here I am multiplying this 6 into 1 to make 6 only. So that the number of hydrogen atoms on reactant side becomes equal to the number of hydrogen atoms on product side. So this is also 6. So this is also 2 into 3 is also 6, and hence the hydrogen is balanced. And now this is the resultant equation. You see, C2S6 plus O2 gives to CO2 plus 3 here. 3 is multiplied, 2 into 3. This 3 is this 3 you have to write here. This 3 you have to write. So this 3 times H2O. So now we came to this step. Next step, we have to balance the carbon, because you see in this table carbon, on reactant side 2 carbon atoms are there. On product side only 1 carbon atoms are there. So their number has to be balanced. What to do? So now balance the carbon atoms. So on reactant side, you multiply these 2 into 1. And on product side, you multiply 1 into 2, so that the number becomes equal. Because on reactant side, 2 carbon atoms are there, but on product side, only 1 carbon atom is there. So that's why I am making this 1 into 2 to balance the carbon atoms. Then you write the resulting equation. So the resulting equation now becomes C2H6 plus O2 plus 2O2, 2CO2, because here this 2 is multiplied. So this 2 you have to write here. So it becomes 2 CO2. Here 2 is not there. Here 2 came because you are multiplying this CO2 by 2. So 2 into O2 plus 3H2O. 3H2O already balanced. And now what happened? You balance the, now you check for the carbon atoms. Here 2 carbon atoms are there, and here also 2 carbon atoms are, hence it is balanced. Okay. And hydrogen, here 6 is there, and here 3 into 2 is 6 is there. So hydrogen is also balanced. And lastly, we have to balance the oxygen atoms. Because oxygen atoms, you see here 2 are there, but here 2 plus here 1, 3. Here product side 3 are there, but here 2 are there. So that should be balanced. Now what you do to balance the oxygen, multiply O2 by 7 by 2 and whole equation by 2. So this we have to do. Multiply O2. O2 is here. To this only we have to multiply by 7 by 2. And then we have to multiply whole equation by 2. So what happens? This 2 is multiplied here. 2 C2H6. So it becomes 2. For this O2, first you are multiplying by CO2, then you are multiplying by 2. So that 2 to get cancelled, 7 remains here. So 7 remains here. And on this side, we have multiplied the whole equation by 2. So that this 2 into this 2 becomes 4. This is 4 CO2 plus this 3 into this 2 becomes 6. So it is 6 H2O. And lastly, what happened? It becomes 2 times C2H6 plus 7 times O2 gives rise to 4 CO2 plus 6 H2O. Now the balancing is over. Check for the balancing of the equation. And a carbon on LHS side, how many carbons are there? This 2 into 2, 4 is there. And on the product side, say here 4 carbon atoms are there. So 4 is right. It's right. Then hydrogen atoms you have to balance. So it is 2 into H6. So 2 into 6 is 12. And plus 6 into 12. Here 6 is there. 6 into 2 is 12. So it is 12. So hydrogen is also balanced. Next, oxygen is there. And here 7. 7 into 2 is 14. And on product side, it is 2 into 4 is 8 plus 6 oxygen. So plus 6 is 8 plus 6 is 14. And hence all are balanced. So this is how we are balancing a chemical equation. Here is the one more example. So balance the given equation. Na plus H2O gives rise to NaOH plus H2O. This is the given equation. Write the given equation in this way. Next, put the bracket. Okay, so you have put the bracket here. And write the table for elements. Elements, LHS, RHS. What are the elements involved here? Sodium is here, and hydrogen is there, oxygen is there. And what are, write their numbers. So sodium on LHS side is 1 because here only 1 is there. And RHS side also it is 1. Hydrogen, LHS 2 are there. RHS 3 are there. Here 1, here plus 2, 3 are there. Next, oxygen. Here LHS side 1 is there. And RHS side 1 is there. So in this way, sodium and oxygen are already balanced, but hydrogen is not balanced. So that we have to balance. So hydrogen has the maximum number of atoms, it should be balanced. So simply what we are doing, multiply this H2O on LHS side by 2 and multiply NaOH on LHS side 2. So sodium hydroxide is on product side, you multiply 2 to that. And this water is on product on the reactant side, you also multiplied by 2. So what happens, you see, it becomes Na plus here it becomes 2H2O, gives rise to this one is 2NaOH plus this is a hydrogen. And now check for the balancing. Sodium here is 1, here is here is 2, but it's not balanced. Okay. So here 2 sodium are there, and but LHS side only 1 is there. Next, hydrogen. Here 4 are there. 2 into H2 is 4, and here is here 2 plus 2. Here 4 is there, and oxygen 2 here and 2 here is there. So oxygen, so hydrogen and oxygen are balanced. Sodium we have to balance. So now to balance the sodium, multiply Na on LHS side by 2 and RHS 2 NaOH is there 2 by 1. So it becomes 2 Na on reactant side because this 2 is multiplied to only sodium. So it becomes 2 Na and plus this you write as it is, this thing into 1 and this is there. So totally it becomes 2 Na plus 2H2O gives rise to 2 NaOH plus H2. So now after doing this, check for the balancing of the atoms. On LHS side, check for sodium. Here 2 sodium atoms are there. Here 2 sodium atoms there. Balanced. Next, check for hydrogen. Two hydrogen atoms are there. Hydrogen atoms 2 into 2 is 4. And here 2 plus 2, 2. Next oxygen, here 2 are there, 2. And here also 2 are there, 2. So in this way, all atoms have the equal number on LHS side and RHS side, or on reactant side and product side. Hence, the equation is balanced. In this way, you have to balance a given chemical equation. So these are the so many examples available for the chemical reactions. We can balance them one by one. Okay. So I will cover these two questions, small questions, so that this session gets over. So just I will discuss another two questions. Here one question comes. Why is hydrogen peroxide kept in colored bottles? This is the question. The answer is to avoid the incidence of light on it, because hydrogen peroxide decomposes into water and oxygen in the presence of a light. So that is why, to avoid this decomposition process, we have to keep the hydrogen peroxide in the colored bottles. So that is the answer. Next is which of the following reactions are either exothermic or endothermic? Burning of natural gas, photosynthesis, respiration, electrolysis of water, decomposition of calcium carbonate. So here, exothermic reactions are 1 and 3. That means burning of natural gas and respiration are the exothermic reactions. Endothermic reactions are 2, 4, and 5. 2 means photosynthesis, 4 means electrolysis of water, and 5 means decomposition of calcium carbonate. So this is the answer. So next question is, what type of chemical reaction takes place when limestone is heated, a magnesium wire is burnt in air, electricity is passed through water, ammonia and hydrogen chloride are mixed, silver bromide is exposed to sunlight. So here, on the basis of the chemical reaction, we are grouped like this. So decomposition reactions are 1, 3, and 5. 1 means limestone is heated, 3 means electricity is passed through water, and 5 means silver bromide is exposed to sunlight. So these are the decomposition processes. And combination processes are 2 and 4. That's a magnesium wire is burnt in the air, and ammonium and hydrogen chloride are mixed. So these are the combination process. Next question is, what is a catalyst? Catalyst generally either decreases or increases a rate of chemical reaction without itself being consumed in the reaction. So they are called as the catalysts. Next question is, why should a magnesium ribbon be cleaned before burning in air? So due to oxidation, magnesium oxide is formed over the magnesium ribbon that avoids its burning. Thus, it should be cleaned before burning. So these are the question and answers and the balancing of chemical equations we have seen, which is very important point. And in the next section, I will balance some few more chemical reactions so that you understand the process or method completely. Thanks for listening.